Alright guys, so now we're moving on to part 2 of the video. This will be a proof contradiction to contrapositive, and then a more advanced contradiction to contrapositive. So if you can understand these two, then you're definitely well set for this topic. Okay, so first one, use contradiction to contrapositive to show that 1 divided by an irrational number is irrational. We have a statement P that A is irrational, and then if P, then Q is that 1 over A is irrational. So it's contradiction to contrapositive, so we'll be starting with not Q leads to not P, and then as it's a contradiction, it has to be not Q and P would lead to P and not P, or Q and not Q, just like I said above. And then we would have, so let's first assert not Q and P. That would mean that 1 over A is rational, that's not Q. So we can write this as 1 over A. So not Q and P would mean that, so basically we're saying not Q and P, that means we're saying that A is irrational. So by saying that not Q and P, we're also trying to, okay, so this is basically what we're trying to say when we're saying not Q and P. We're saying that A is irrational. When we solve it out, we get A equals n over m, which is, of course, rational. So it leads to a contradiction right there. And that's our proof by contradiction. Basically, we did, let me just explain it again in case you didn't fully understand. We did that if we say not Q and P, we assert both of them. That means we're asserting that 1 over A is rational and A is irrational. So we solve it out, we get that A is irrational and rational. So it leads to not P and P. Again, the next problem is use contradiction to contrapositive to show that if A is rational and B is irrational, then A squared plus 2B is irrational. Okay, so again P leads to Q, so not Q leads to not P, and then we have to assert that not Q and P would lead to P. Let's do P and not P. Okay, so there we go. So now we're going to start solving it out. So not Q would be that this is rational, so not Q would be A squared plus 2B equals m over n. It's a rational number. And then we also have to be asserting that A is rational and B is irrational. That's what P is. So so P is, let's focus on the statement of P that B is irrational. That's what we're going to focus on. So when we solve this out, we're going to get 2B equals let's just simplify this further. And then, of course, because A is a rational number, that would mean that the whole thing has to be rational. So basically, by definition, we're getting that B is rational but the thing is, when we were trying to assert and P, we were also trying to assert that B is irrational. And then so we get a contradiction right there. That I don't know if I fully explained it, but basically we tried to assert not Q and P, and we that led us to be getting a definition that B is rational when but at the same time we were trying to assert that B is irrational. So there's our contradiction. And yeah, so that's how we just prove that. Alright, so that wraps up the video. I hope that fully explained everything. I know this part 2 was a little bit faster than the part 1, like probably like twice the speed. But yeah, thanks for watching. And remember, no fear, Ayush Saha is here. So good luck in the course.